explain to you and them at the same time the basic premise. Basic premises is, you know, when I try to be as involved and contribute as much as I can to Datapalooza planning, and we recognized, all of Academy Health recognized 6 months ago that, you know, patients were not going to be able to travel. We're in the middle of a recession, so it's expensive to travel. Some people just can't afford it anymore. And then also we are, I don't know if we're at the end of a pandemic or the beginning of an endemic or in the middle of a pandemic, who knows where we are, but COVID's still a thing. And so if you're immunocompromised, which a lot of patients are, you can't travel either. So Datapalooza has always been a patient-oriented, patient-focused conference, and we wanted to continue to do that. And it turns out it's exorbitantly expensive just to stream the cameras from the main stage. So the alternative that we came up with was we rent a suite, get access to the good hotel Wi-Fi that's in the rooms, which is stable enough to provide a connection, and we do a kind of post speaker stream here. And what that does, it creates a permanent record. So these things will be posted on YouTube. We're streaming on YouTube, Twitter, and LinkedIn, and two of those allow kind of for permanent storage of videos, and so they'll be up there and you can refer to them. So that's the reason we're doing this, and the reason why we're doing it in this kind of somewhat strange way. And with that premise explained to both the audience and to the two of you, please introduce yourselves and say why you're here at Datapalooza.
Sure. Don, you want to? Okay. Yeah, I'll go first. So I'm Ricky Sahu. I'm the Chief Innovation Officer and founder of OneUp Health. And at OneUp Health, what we do is we help health plans get all of their claims data and clinical data, transform it into FHIR, and make it available to, you know, all the patients out there with those health plans.
Yep. Don Rucker, former National Coordinator Chief Strategy Officer at OneUp Health. I joined OneUp Health now about a year and a half ago, and really the goal is to have modern computable data for everyone. You know, initially we're largely doing a payer-facing and apps as our first two sort of broad sets of customers, but the goal is simply to use modern APIs, so RESTful APIs and FHIR, and make healthcare thoroughly more efficient by combining claims and clinical data. So that's what OneUp Health is all about. And we have about 70 payer customers, so quite a footprint at the moment.
Well, congratulations. I think you are one of several companies that are demonstrating that FHIR is a reliable kind of business infrastructure tool, and that's a change. So, I mean, if I was advising a company, I don't know, 5 years ago, I would have said you're better off just going and working with the various EHRs that have good proprietary APIs. Maybe I think at that time, Athena Health and Health Groups both had kind of okay APIs, and that was a good strategy at that time. And now I would say, you know, FHIR is mature enough that maybe it's something you should really look at and lean on. And because there's all of these potential intermediary players that are making that much easier. Can you explain generally how your company makes it easier?
Yeah, so I can go ahead. Basically, what we're doing is we are working with all these EHR organizations, but now FHIR is also, you know, taking the leap into the payer market. So there are hundreds of health plans that have FHIR data available as well. So what we do is we work with those providers and those payers directly and build those connections both at the patient level, which means one patient can authorize access to their data to any app of their choice, and at the population level, which means that two organizations that have business associate agreements between the two can authorize population or bulk data sharing between those organizations. So for example, a payer that wants to work with a provider for a member population that is treated by that provider organization, they can get hundreds of thousands of patients shared rather than just one patient at a time sharing manually.
Sounds good. So, and the kinds of things that payers beyond FHIR should enable is I change my provider, my employer decides that we're getting a new insurance company, and maybe they already know that I have a script for whatever I have, and it doesn't necessarily have to be this big thing. And, you know, it's not this from scratch renegotiation. Those kinds of benefits that the public is intended to get. I want to skip to another topic if it's all right. We
Sure.
had just briefly mentioned, and I'm sorry, my acronym soup. Well, first of all, we're trying to not use too many acronyms
Yeah.
because we're trying to make something that's accessible to patients.
Right,
So I think it's TEFCA, but I feel like it might be like Tesco. That's not right.
Yeah.
That's an oil company. Teflon. That's something else.
Yeah,
So what is it exactly?
Yeah. So before we get into the specifics, I think what really is powerful about FHIR is it is a global standards based on JSON, right? So the entire internet basically runs, every app on your smartphone is communicating back to its servers using RESTful and JSON. So this is the standard of the world. And that's the real power of FHIR. To your earlier question, that's what makes it, amongst other things, highly computable. I think the real opportunity is in computable data, right? In the old days, it was just sort of a document, right? Well, when I started, it was a paper medical record and photocopies. And you would like take a version of your chart and, sort of move it somewhere. There's, as a side note, there's the Cures Act, not fully understanding how networks worked, had a provision for something called Trusted Exchange Framework Common Agreement, TEFCA. There's been some proposals around that. That's sort of the old style of doing computing. So it's a document centric. It's a 1990s, right? So to put that in context, it's sort of the era of AOL. So some of this audience won't have any idea what the internet was in the 1990s, but unfortunately I do. And the internet in the 1990s, you couldn't actually do anything. It was just a document store. I mean, it was like a big thing. The first time you could ever do a credit card on the internet. We're not talking about data, computing, seamless apps that require lots of computation around individual data. It was just, you could find a document. TEFCA is somewhat ironically a step back into that sort of 1990s document architecture. Obviously, some of the EHR vendors, frankly, to be blunt, have business models with their providers where data sharing is not part of their business model. So having non-computable data is something that they support. In TEFCA, I think for the folks who want to do modern computing, who want to do apps, who want to do, look at a population to improve care, having individual documents gets you honestly nowhere. So that's sort of a little bit of a side note.
Okay.
As we sort of look at some of the policies.
Can you explain with a little more color what you mean by computable, right? Because you don't literally mean computable in the sense that you can compute a document or you can show it or you can use it on a computer. So you mean something special.
Yeah, what I mean with computable is that you can take an individual data field and put it into an algorithm. So you can readily, without complicated and noisy parsing, I mean, you could parse a document, but it's basically in some level the difference between structured and unstructured data. There are certainly many things you can do with unstructured data, increasingly more, but ultimately structured data, right? The data that sits in a database, for example, is what really is the biggest driver of value, right? If you want to, for example, do something extraordinarily basic, like monitoring blood pressure and seeing the appropriateness of blood pressure apps, you need to, in a consistent way, be able to pull out, and have the data fields of the blood pressure, the patient's medical conditions, and the meds they're on, right? You don't want to be, parsing that out of a narrative node.
Yeah, computable is basically, there's a gradient of, less harder to work with, less computable, to easier to work with, more computable. And in healthcare, we started with kind of HL7, EDI sort of files here. And then we went to CCDA files, which was everything in the kitchen sink, to bite-sized JSON objects of FHIR, which is far more computable. And the point is that it's also, like Don was saying, that's how the rest of the internet, the rest of these applications work. So what it did was it made it far more accessible to the common developer who does not have to have all the contextual knowledge of healthcare before they're building a novel application.
So let me mirror back an example to you. You tell me whether I'm right. So I found out on a recent business trip, fun little story, that I'm allergic to soy. Who knew? But I had enough soy in Japan, where soy is a common ingredient, that I figured out that I was having an allergic reaction. And so that if I went to my physician and I said, I'm allergic to soy, he wrote down the note, and inside the note, Fred is allergic to soy. He just found out, business trip, funny story, whatever.
Yeah.
Well, that's not the same thing as having that same information codified on my allergy list. And if it's codified on my allergy list, we can imagine, say, an app that a patient might use that would send an email to the chef of a restaurant saying Fred is allergic to these ingredients. And when you say the word algorithm in this sense, and of course algorithm to a computer scientist, we say the word algorithm, and all we mean is a recipe that a computer could follow when we say the word algorithm. So the fact that you could say reliably send an email to the chef, or have the chef have an app where they were looking at something, and so it was kind of like Uber, but except it was Uber Eats, but considering your allergies, or those kinds of features. That's the example of exercising a kind of structured data field where you couldn't do that if it just had a note written, Fred has an allergy to soy, or no soy for Fred. And because there's 10 different, 100 different, 1,000 different ways to write that story in a note, that's not something that is easily computable and can easily participate in that app that solves this problem for me.
Yeah. So the
Is
way,
that right? Am I talking the right kind of things?
Precise. Yeah.
So
precisely.
the way like you telling your doctor, I'm allergic to soy, the way that would work or should work today is the doctor, yes, they might write in a note, but they also have an allergy section in their EHR where they, take the drop down, put the exact, codified way of saying soy allergy. And then that is required by, these FHIR-based rules for a provider's EHR to make that allergy intolerance FHIR resource available via API to any app that you authorize access to.
So the electronic healthcare record, which is the EHR stands for when we get rid of that acronym, which is the thing my doctor's typing into, it has to communicate and talk to other EHRs, other systems, maybe a system from a payer, maybe an app. And when it does, whether or not something is in the note versus in one of these structured sections ends up really mattering. And it also ends up really mattering for the FHIR standard. FHIR is FHIR, stands for Fast Health Internet Resource. Is that right?
Healthcare interoperability resources.
Okay. So, and of course, everybody loves it because it sounds like the word fire, and that's very fun. And that standard, there's been about 6 or 7 standards, a couple that you rattled off, but X12 and IAG, that really didn't stick well enough to cause actual health information exchange to happen. And it does seem like FHIR is popular enough to stick. Is that
there are a couple of important nuances there. So X12 is a relatively straightforward thing. It's part of HIPAA and EDI. The problem with
Which stands for
electronic data exchange. So payments.
And it's a very old school. It's the old school way of communicating financial data, and it works very, very well.
It works extremely well. Trillions of dollars change hands every year that way. Maybe it works too well. That's a philosophic thing on healthcare. But, it's been part of this balkanization of healthcare data where we can't combine financial data and clinical data. Part of what FHIR allows you for the first time to do, and we make a market in this by disclaimer, is it allows you to take X12, put it in FHIR, and have a uniformly computable thing. The other thing you mentioned that's sort of critical is how are the various entities going to even know they exist and communicate? So How do you know in any of these things, if you're going to get individual records, right, you somehow need to have knowledge of an API. And a large part of that is, where directories of API, there are some things like record locator services. CMS in the Cures Act has a requirement to build a provider directory. And I think that is going to be very important. Some of the putative benefit of TEFCA is that and the insertion of a new layer of brokers, so-called QHINs, into that. But these brokers are sort of not great brokers, even theoretically, let alone in practice, because it doesn't change the actual work, which is, if I want your medical record, if I'm taking care of you, in the ER or something like that, I still have to do all the work of figuring out where your medical record is, right? Whether that's a broadcast query to, like, you tell me that you got care in Arlington, Virginia, where we're sitting, and I go to all the providers nearby and say, hey, did you see this guy, Fred? Or is it a directed query where you told me you got care at Inova Fairfax, and I send a thing to Inova? So you still have to do all of that work, right? The app, the API, the front end. So do you really need a broker for that? Do you need a middleman for that? Actually, you don't. Part of what the whole RESTful world is, it makes getting to these endpoints really simple. So instead of having complicated broker transactions, that's why IHE hasn't really worked for the most part. It's been around since the 1990s, is because you have these very healthcare specific, very idiosyncratic, non-modern ways to get at the data. It's just grossly inefficient. And ultimately the goal there from some of the parties is to not give you the data to begin with, right? Because the assumption there is the data will still be in the EMR, under the control of the EMR vendors, and you won't get it without going through brokers and stuff. The ONC and the Cures Act API rules that are out there have a totally different policy assumption, which is it's your body, your data, and you have an economic right to use that data in as efficient a way as you can make it, and the market can make it for you, whether it's a company like OneUp Health or Amazon or whoever. It's a extraordinarily different philosophy that's out there. I think standardized APIs are going to win. That's sort of the way of the world wherever you look. But that's just sort of a side note in play today. I think the real thing the audience should focus on is, when you have these standardized APIs, what are the things you can do? So part of those rules that we make a market in is generating for payers the combo of clinical and financial data in APIs out to patients, out to other payers, right? Coordination of care, prior authorization, and now under the proposed rule, out to providers. And to do that in a way that's elegant and computable. And then you can start looking at all of these things that bedevil the country, like access. What's your network design? You can make that rational more easily. Quality of measurement, the search for value, which has been a national conundrum for probably 2 decades, I would say. And now the latest one that's come up is prior auth, where people are very unhappy about it. And the federal government, Congress are doing a lot of work to increase transparency. So all of those things come in when you have modern infrastructure. I don't know, Ricky, you've been in this space as well.
Yeah, I think that the key point in that is that FHIR is the first time that both payers and providers have been able to speak the same language. Before, payers had their 837s, their EDIs, all the financial data was locked there. Providers had their, HL7 V2, CCDAs. None of them spoke the same language. And by bringing the claims and clinical, the financial, and the actual healthcare data together, you we're really going to see this industry be able to run analytics and population health use cases that are able to say, hey, these clinical findings or these treatment plans actually have an impact on the cost in this way, and how you would optimize your provider network or your formulary to better treat the patients. So it's like bringing a common language like English into the world, and now both organizations can be native speakers and not have to deal with the overhead of translating between each other, dropping half the data because they don't understand it.
Well, I've met enough Australians and Canadians and British people to know that sometimes people can be separated by a common language. So, and I think we're going to probably see a little bit of that with fire in the short term.
This will, this is going to sort of, those edges are going to sort themselves out, honestly.
Which, I mean, coming from a former ONC, I think is a brilliant place to kind of end. I know you have other things you need to get to. I think that's not actually been obvious before. I think there's been eras, and I've been hopeful in the last 2 or 3 eras that whatever the standard was going to make things out. But I did think that there seemed like under the Obama administration that IHE was going to have legs, and that direct was going to be a simpler version of that. And I think direct has survived and probably will be around, but fire is going to replace IHE, and I think it'll be a lot of fire and a little direct. Probably is how things are going to work in 10 years. That's my guess.
I think you're spot on. I mean, for the audience, I know there's some sort of oddball discussion about somehow trying to graft fire onto the IHE stuff, a little bit like the, early efforts to put an engine into a horse-drawn carriage, but still use the horse. It means there's a little challenge there. I think these things are going to go on the ease of computing, right? Because the easier the computing, the more you can do amazing things, right? Our customers are now able to do things they've never done before. And that's what sort of dominates and pushes out.
I think it's a very powerful insight. And I really do appreciate just your definition of ease of compute is the use in algorithms. And I think there's, I think what your point is, and I think this is very insightful, is people have talked for years about how difficult it is to do what is called semantic interoperability, which is the person who's receiving the communication truly understands not only the everything that is said, but they understand the underlying meaning, and that understanding is transmitted correctly, which is what we mean when we say semantically interoperable. But if you are just really clearly syntactically interoperable, you get all of this low-hanging fruit from a computation perspective, where there's all these features that we really need, like prior authorization to be reasonable is a perfect example, that do not require semantic interoperability. They are simple syntactic things. It is not that there is a meaning being missed. It is that there's no conversation happening in a formal way, and there hasn't been for a long time, and it's just one of these things that's kind of gotten out of hand. So
everyone's speaking a completely different language.
You're spot on, right? The nature of the fire resources handles that sort of bridging of low weight semantics, if you will, with actual computable syntax is critical. That's where documents are non-computable, right? Because in a document, you get none of that, right? You have to parse it out, and who knows, Ricky plays a doctor in his computer. I play on my computer, sometimes in real life. But, his understanding of, what the patient is might be subtly different than mine, and in a document. But when you have the discipline of putting in a fire resource, we got to sync up somehow. Right. There's just a lot of entropy that's removed.
There's a lot of what I would call architecture astronauts, who are people who would love us to solve semantics right now. And in some cases, when it is possible to do that, we should be as semantic and interoperable as we can. But I think what has happened in other areas, what happened with the internet proper,
Yeah.
is that we kind of use this kind of OSA model to get things right, and then higher and higher levels of abstraction were useful.
Yeah.
Now we don't think about whether or not TCP/IP is delivering something. It's not a consideration. We're just streaming, right?
Yeah.
But we're just thinking in these terms. And so, like, once an abstraction becomes reliable enough, there will be semantic tensions. And I think that probably not this decade, but the next decade will be all about how we didn't necessarily get semantic interoperability correct. But that is the right problem to have. It's a privilege to have that problem, because it means that you're communicating so much that subtle differences between the ways you're thinking about a topic are starting to actually matter in the interchange. But now we're not even talking, right? So it's just like anything is better than what we're doing right now. And we've been trying to crack that nut for so long. I really am happy to see some of the cleanest parts of what the internet is, using DNS, using OAuth, using REST, using JSON. And I apologize, I'm not going to define all those terms for our audience, since I want to respect your time and get you off the stream in something like a reasonable time frame. The cleanest parts. It's not just that we took internet standards. We took the cleanest internet standards.
Best tested,
widely used, rock solid.
Yeah.
And we didn't take some of the more problematic ones, frankly, and then pulled them over.
That's spot on. Right?
So
that is.
Because we could have done XML RPC and SOAP.
Yeah,
like,
yeah. I mean, that's exactly.
That's not what we did.
Yeah, I mean, that's the stuff that didn't work, and should probably not.
We should probably not say that.
Yeah,
I apologize for saying that.
It's interesting that the more robust you have the underlying data in FHIR, and having simple, elegant APIs as opposed to sort of kludgy APIs that we started with in the 90s in healthcare. Some of the semantic things are, I believe, going to take care of themselves by the volume of data, because semantics is ultimately about context, and the more computable data you have, the less you have to worry about.
That is an excellent point.
The less you have to worry about the context, because you're going to compute around the context. The more
You're very optimistic.
What?
You're very optimistic.
I've been doing that. I've been doing this for 40 years.
Danny is in the peanut gallery here.
Yeah, I've been doing this for 40 years. I've been in.
Well,
I would say I would actually question your optimism.
Well, I think he's right to be optimistic, but having said this, I think he is cautiously optimistic.
Yeah.
And I think it's it's one of those things where the reason I am optimistic, and I actually think you should criticize me too for that optimism for exactly the same reasons, is that I have seen the efforts and the great energy that's gone on, and I've seen how far it got with IAG and with these previous standards, which while I criticize them, and I agree they were inelegant and not necessarily based on the best technologies, the reason they didn't get far enough is because they weren't adopted. If they'd been adopted, we'd be using them. X12 is a very inelegant thing that runs the world of claims finances, right?
Because it does have a simplicity to it.
Well, it has a simplicity to it, but it was also full and perfect adoption, right? And it very nearly 99.9, I think they're getting into the second nines of claims are using that electronic standard as opposed to paper. So the adoption is just through the roof. And so what I have seen with FHIR is adoption. And that is what gives me optimism. It is not a blind optimism, but the adoption that I have seen, the fact that you have as many payers working with you in your business model, and I hear other companies that are, have FHIR in their spine having similar levels of success, that level of adoption is what gives me any kind of optimism at all. But Danny, when we start to interview you in the next session, we should start immediately from, should we be optimistic?
There's one subtle point on X12, which is the simple parts of X12 have succeeded. Now, arguably, some of that.
Oh, that's a good point.
Ruled,
actually, there's a whole bunch of X12 that's not used.
Claims attachment and all of that has been absolutely unused because it didn't fit. It wasn't ultimately fit for purpose. So when you think about that, it all gets back to: is this something computable and simple, or is this something that's sort of Byzantine and doesn't really have a standard, or is so headache generating that it can't be used? And that's obviously the challenge with some of these sort of elaborately brokered architectures is they've stripped out all of the simplicity to sort of lock the data into the guilds. And, obviously the guilds have done pretty well in American healthcare. It's obviously a question of how much that continues. But I think we're seeing the world of computing. And some of this is because the payers have been better at adopting these things than providers, right? If you look at Walmart, Walgreens, CVS, Cigna, Amazon, right? All of these folks are today coming at the inefficiency in healthcare with sort of compute first, primary care first type of approaches, where they control the information flows, right? Because all of those business things are also IT strategies, and they're, in some ways you could argue IT strategies first, depending on how you frame the problem. So there's a lot to unpack there. I don't know.
Absolutely is.
I cut you off. That's
Well,
what you
yeah,
got to say.
Do you want to say something else?
Yeah, just at a high level, I think we'll probably see Fire solve for maybe 80% of the broader use cases and the data exchange and the information that needs to be transmitted through syntactic validity. But that semantic stuff, as it is available in Fire, but it is buried in the notes. But I think that's where things like AI and other machine learning approaches come in, and that will maybe get us to 95, 98%, and then we have humans for the last little bit, but hopefully will still be necessary.
So with a note that we are hopeful, possibly inappropriately hopeful, I think that's a good way to say. I will plug my own book. I did a bad job because I wanted to keep things short of going through and trying to say what every acronym meant and what X12 is. And we said 837 a bunch of times. And that is the worst way to talk about X12, because everyone who's dealt with X12 knows exactly what it is. And people who are like, what on earth are they talking about? Is that a zip code? Is that a phone extension? What is that? So it's not an area code.
Yeah.
That's part of the X12 standard. And I on the new stuff on the AI, the book that I wrote 10 years ago is totally useless. Doesn't have any of that in there. But the book that I wrote 10 years ago talks about IHE, it talks about X12, it talks about all those things. And so please go buy my book if you want to have the experience of learning those acronyms. And what I recommend instead is that you learn Fire and not buy my book, and you'll have a much better life. So so that is the unrecommendation that I will make for my own book. And I think it's a good place to end the stream. I really appreciate you guys coming up and talking to me. Thank you so much.
Thanks.